Okay, in previous video we discussed when the force is applied F, then the limiting frictional force will act in opposite direction. Sound chedra mu s into mg. Okay, we can write F minus mu s into mg by we know that from Newton second law we can write F net is equal to ma F minus mu s into mg by m we will get the acceleration by substituting acceleration in above equation. S is equal to half a t square. We may ask displacement, we may ask velocity, we may ask about distance traveled in nth second. This type of questions are supposed to ask from this chapter. Okay, next we will discuss about next topic is here. See, when a frictional force is applied at any angle theta, see here the frictional force, here the body is in the horizontal rough surface. Okay, I am applied force F. I am applied force F for this against frictional force will I am applying sorry, I am first I am here applying pulling force. I am pulling the body. See, I am pulling the body. Okay, now pulling the body means here it is we can split into two components. In second chapter motion into sorry, in third chapter motion in 2D we will have discussed about splitting of the component of vector. Here the force can be split into F cos theta and here F sin theta. This component will be opposite component will be F sin theta. Here normal force will be acting upward. Here see, we can write mg is acting downwards. As the body is not moving in upward and downward direction, it is in equilibrium. We can say that F sin theta plus normal force is equal to mg. So normal force can be written as n is equal to mg minus F sin theta. Okay, now from this frictional force we know that any frictional force is equal to mu k into normal force is mg minus F sin theta. Okay, now for same body it is a case of pulling body. When the body is pushed on the rough surface, see, when the body is pushed on a rough surface, it is a force applied. We can split into two components. They will give angle with respect to horizontal. So it is F cos theta and it is F sin theta. We know that when the body is not moving in upward or downward direction, we can write that normal force is equal to mg plus F sin theta. So frictional force can be written as mu s into mg plus F sin theta. If you observe in this case, frictional force is acting more in a pushing case. So we have to apply more force in pushing case. So pushing is difficulty. From this we can pushing is difficulty. In short form, we can say that pulling is more easier than the pushing. Okay, now next we will discuss about vertical. Then we will discuss about vertical. Then we will discuss about the friction in vertical surface. Friction in a vertical surface. Okay, now here suppose the body of mass m is again then here the force F is applied against the wall to make the block of the mass to stand against the wall. Here mg is acting upward. Here frictional force in the upward direction, mg downward direction. Here the normal force is perpendicular to the body. From this we can write normal force is equal to F, and as the body should not move means